I'm going to do an oscilloscope review. This came from Banggood. Thank you very much, Banggood, for buying something at no cost. We'll take a look at it. Let's power it up, have a bit of a play around with it, see how it looks, see what it compares like to other oscilloscopes I've played with. These are more budget conscious scopes, so if you're like a beginner and that sort of thing, then you probably will be interested in having a look at this and see what it actually performs like, and I'll give my opinion compared to other scopes I've played with. Maybe make a recommendation or not, I don't know. Each scope has got its pros and cons. They've all got their little, things where they'll do something well and something else not so well, and it's a case of trying to find out what will work for you. Having a range of different scopes to look at is sometimes helpful, which is why I've done these different reviews. So check out my reviews at the end of the video here. There'll be some cards that pop up at the end, and they'll be linked to my teardowns and reviews playlist, and in there will be other oscilloscope reviews. I've done Unity, Handtech, numerous Siglent scopes. I also own Siglent scopes up here on the bench myself, and we're going to look at this one, which is still a mystery. I haven't told you what it is yet, but stick around, we'll find out. Something else I'm thinking about doing is a oscilloscope giveaway. Now, maybe not right now, but in the future I'm going to do a giveaway to my Patreon supporters. So if you're interested in potentially going to draw to win a scope, could be this one, could be one of the other ones I've reviewed, like the other budget scopes, not a Siglent one. So the Handtech, the Unity, or this one. I'm not sure which one I'll give away yet. It depends on which one suits me the best, I suppose. So I do intend to do a giveaway to my Patreon. So if you're interested in potentially being part of that giveaway, maybe become a Patreon. What I'll do is I'll set a threshold, so once I reach a certain number of Patreons, then I'll do the giveaway, because I have to obviously cover my costs and shipping it and stuff like that. So I don't want to do it at a loss. I don't mind giving it away for nothing, because it hasn't cost me anything. I don't want it to cost me money in the process. So if I've got enough Patrons, then it will pay for it that way. If you are interested in becoming a Patreon, check the links down below in the description, and also at the end of the video there'll be a little button to click on at the end as well, on the little pop-ups that come across the end. I'm not going to tell you what brand it is yet. If you've seen a mailbag video already in the future or in the past, you'll get them on when you see it anyway. I can't cover this anyway, but anyway, so we've got a power cable, and it did come with a depth adapter, one of these. Very commonly sent, very handy to have if you have the wrong power cable like this one. These kinds of things, I wouldn't keep this, I'd chuck this away. But I might include it if I give this thing away, because it may suit the country, whoever gets it. I'll figure it out anyway. So, power cable, USB cable, USB A to B. Got some probes, which are 100 MHz probes, T5100. Got a CD, the quick start guide. I guess the CD's got software or potentially manual or something like that on it. Let's have a quick look at the quick start guide. Quick look at the quick start guide. See what I did there? Just general stuff there. Safety precautions. If you never used a scope before, don't kill yourself by doing something dumb. So yes, it is just telling you about the ground referencing on the scopes, because if you're not used to scopes, and it's careful with the actual B and C cables, and then these probes, the negative clips on these probes, are ground referenced, earth referenced. So that is like an earth point. So if you stick that onto something which isn't earthed or isn't floating, you can blow up the front end of your scopes. That's something to be mindful of. All scopes are the same. I don't need this because I'm pretty familiar with scopes anyway. Get it unpackaged. So if you haven't been to my channel before, make sure you click the subscribe button and the bell icon as well, so you're notified about new videos if you want to see more of my stuff, reviews or electronic repairs or whatever I'm doing, mailbag videos. I'll do a little mixture of different things I do, so some of those might interest you. It's a Mustool MDS2112P, which is a 100 MHz 1 gigasample per second sample rate scope. Obviously 2-channel in this case. It's a fairly sparse panel, I suppose, compared to some other oscilloscopes, but in a way it's also a good thing, because if you're new to oscilloscopes, not really used to them, a simplified interface like this is probably going to be beneficial to you. It probably won't restrict you too much in what you can actually do. So we have various controls. Obviously you've got B and C inputs just here behind these little covers which help protect them. Leave those on for the time being. Vertical adjustments, these set your sensitivity, vertical sensitivity. These two here, one for each channel. These are clickable as well, so they have secondary functions by clicking them. Nice feature. Not all scopes have that, some do, some don't. You've got channel 1, channel 2 buttons here. These will be enabling and disabling the digital channels, and also probably bringing up menus relevant for that particular channel you're working with. Math function, that's nice. You've got position controls, also clickable. Probably one for each channel. Sometimes I share them. That's the horizontal position, also clickable, which is 0. So when you click it, it goes to 0. Multi-purpose knob, which would be for various menu options. So whether you're doing the menus, you'll be selecting things with this and clicking it. to select. Utility button, measure button for doing measurements. Auto set, which is handy. I don't tend to use it myself a lot, but it can be handy if you want to quickly have the scope try and find the signal you're trying to find yourself. Acquire menu will be various functions. Run, stop button, cursor button, probably on screen cursors. We have a scale, which is a horizontal time base, seconds to nanoseconds. That tells you that way you're going slower or capturing more data on the screen, and that way you're zooming in basically. And that's also clickable. Then we've got a trigger, not indented, also clickable, which is nice. So it has these, every single one of these buttons is clickable, so they all got zeroing, which is nice. You've got the trigger menu, false, which is false trigger. I guess that means when you push that, it does a trigger regardless of what's going on. And a copy button. And over here, in the bottom corner there, we've got a couple of connections which you can't see too well because I'm side on. There we go. Those are the scope probe for doing the calibration of the probes. So you set the probes up on that. And you've got a USB port over here and a power button, which is a hard power button. There we go. Get the lighting off it. Nice. Hard power button. I like that. Hard power buttons. I don't prefer them to soft power buttons. But you know it's definitely off. And on the back, we have a USB port, obviously for that cable that it gave us. Power specs 100 volts, 240 volts in that range. Automatic max power 15 watts. It looks like it has foldable feet, does it? How does these work? That folds out. Right, so it folds out like that. So that's folded in and that's folded out. So I guess it means you can tip it backwards and you can make it a bit more stable by having it folded out. So like this, without the feet out, it's like this. Push that button, it wants to tip, but it's okay. Push this one, no, it wants to tip over. So if you want to push one of these knobs, you have to actually steady it. Okay, so let's fold the feet out and see if it does the same thing with the feet out. So the feet out, it tips backwards quite nicely, which is actually going to give you a better viewing angle for the screen, because usually if you're off angle, it's harder to see the screen. You're not quite so sharp because of the way the LCDs work. You have to be, within a certain angle of alignment. So tilting back like that, it's actually quite good. Now, can I push this? No, I still can't push that one. Let's try this one. No, that one. No, this one. Yes, yes, yes. So these ones you can't push unless you steady it. Oh, I don't know. I did it then actually. No, that would then. Oh, just. Yeah, we better just do it like that. Okay. That's a common problem with these narrow scopes. They're quite commonly like that. Not bad. It's quite a nice angle on there actually. That's good. I do like that. Having the back drop down rather than front lift up is actually better too, I think. I'll probably do 2 videos on this thing. I'll probably do one showing the usage and another one as a teardown. I might do a separate teardown. We'll see how we go with how long this one ends up being. But I'll probably split it into being a teardown video separate by itself. So if you do want to see the insides, make sure you check that video out as well. Again, look at the playlist at the end of this video. Right, I've plugged the power cable in. Power is turned on to the unit. Haven't powered it up yet. So we'll push the power button and see how quick boot up time is. And unfortunately my watch is broken right now. It's over here. I'm waiting for a new battery. I seem to have run out somehow. We're going to have to time it with the video camera. I'll just look at the screen on my video camera recording time and we'll see how long it goes from that. Okay, so ready? I'll wait till it gets 30 seconds. Yeah. Okay, we're there. That's about 22 seconds to boot up. Not too bad. Now this screen actually looks quite nice. Detail looks pretty good. Its resolution looks alright. So some of these cheaper scopes, like I think the other one I reviewed, which was the Unity, had a much lower resolution screen. And it looked a bit jagged, and because as a result of that, this has got a nice looking screen. It actually looks quite good. So that's a good start. Before we do anything really, we need to get these scope probes, open one of these packets up, see what comes in the pack. Probably the most standard things, and we'll hook these up and calibrate the probes, make sure we're ready to go, and then we'll go looking through the menu system and maybe do some measurements and do some tests and see how this thing actually handles the things I can throw at it. See what it comes with. It's probably not going to be too exciting. So we have a little bag with some coloured rings, which is pretty much normal. They all look basically exactly the same. We've got 2 of these little covers which go over the tips, so you can shield the tips, or insulate the tips so you don't short the tips out on things when you're trying to do measurements. And one of these little spring earth probes. Oh, there's 2 of those. There we go, 2 of those spring earth probes. So that's good. So there's a full set there. There's 2 in green, 2 in pink. Now the colours on here are yellow and blue. We have red and yellow on here already. It's a shame we don't actually have blue rings because we've got blue buttons. So if we had a blue ring, we could match the colour of the probe up to the channel. A bit odd. Normally you get rings that match the channel colours on the scope. So we've got the yellow one, that's fine. So that's channel 1, which is here and kind of tangled. The fact there's no blue one's a bit interesting. I probably have some other sets somewhere which have blue rings on them. Would surprise me, I've got various sets lying around. Specs on these say the 100 MHz, 100 MHz or 6 MHz. Now there's a difference between these. This is a common thing on scope probes, but it's not necessarily well known to newcomers. People which experience scopes will know this. But when you're on 10 times range, you've got higher voltage capability and higher bandwidth. When you're on 1 times range, your voltage capability drops right down and your bandwidth drops down to this. Alright, so on 1 times you get that much bandwidth. It's a big difference. So wherever possible we use them in 10 times, which also improves your isolation, also reduces the chance you're dragging down a circuit that you're trying to test as well. Wherever possible use 10 times. Also when you do the probe compensation adjustment, which I'm going to show you in a minute, here's the 1 times and there's 10 times. So you make sure you get these set at 10 times range. You set the switch there and then you do the probe compensation we're going to show you now. Right, let's hook up the probe. As you can see I've got them connected up to the front panel here. So we've got the top one is the actual signal line. There we go. And this one is the ground line, which you shouldn't really need to hook up when you're doing this particular measurement because it's all reference of the same plane inside the scope anyway. But potentially you could get noise induced in the probes, and so it's best to put the ground loop on. So this is what we get. You actually see it's triggering quite nicely. It's got quite a good update rate on the screen. It actually looks pretty good. So do the horizontal scaling, and you can see here that this is not a nice square wave like it should be. This needs adjusting, which is easy. So you've got this little hole in the top of these probes here, and you put a little screwdriver inside there and you trim the capacitor which is in there. So this kit comes with a screwdriver inside the bag, right? So that's what that screwdriver's for. You can't just use a normal metal screwdriver because it will load down and cause effects to the actual probe, so you need to use something which is insulated. I'll turn this around like this, get it out of the way a bit more. Get a bit more off to the side, there we go. Okay, so what we need to do is make these nice square wave. So you can see what the effect is on there. So you don't want to be undercompensated, and you don't want to be overcompensated. You want to be correctly compensated. So the idea is to try and get flat across here and across here on those leading corners. Okay, we'll try and get both. Usually you'll find there's a slight mismatch between them. You don't always get it absolutely perfect. You might get one which is looking good, and the other one might be slightly over or under. Gone too far. When I was pushing on the capacitor, I was actually seeing a change in the waveform here. Now you don't have to be absolutely perfect, but if you want as accurate a representation as you can, then you want to try and get this as nice as you can. Okay, so that's looking pretty good there. Now we'll do the same thing with the channel 2. This one up. And because it's not triggering on channel 2 currently, we can't see it. Well, not very well anyway. So what we need to do is come to the trigger menu, and we need to change it to source channel 2. There we go. Nice and easy. Cut the button pushes. Done. So now we need to do the same trimming on this one. Do the same thing and get this all correctly compensated as well. I've actually done a video just on this in itself a little while ago. Yeah, so I'm getting a bit of overcompensation here just to try and get these looking nice. Yeah, see, it's not quite where I want it. So we're going a little bit of overcompensation. It's not quite linear, this one. It's got a slight offset one way or the other. So this is slightly under, that's slightly over. See, it's got a bit of a bump just there. Okay, but it doesn't matter that much. Some scopes you can get it quite good, other ones not so much. But it's not too bad. This is slightly offset there. I could live with it. So I've put up channel 1 again, just gone back to that, just for simplicity. That's what I prefer to do everything off channel 1, just the way my head works. Let's look through the menu system, then we'll do some measurements and see how it handles various frequencies going to them, see what the bandwidth looks like, that kind of thing. It claims 100 MHz for a 3 dB drop off. We'll actually test that and see what we get. So let's just go through various menus and stuff first. So we'll start up here. Run stop, it's an obvious one. It stops the triggering, restarts triggering. Auto set means it will find the best setup it can for that signal source. It detected a square wave on that channel and it automatically set that up and split it up as well, done a split screen for each channel. So if I turn channel 2 off and do the auto set again, It's automatically turn channel back on again. Even if channels are turned off, it will still turn channel on and find it. That may be a bit of a pain if you tend to only use one channel, for example, but that's okay. Position will 0 that and that one. The utility button, let's have a look in here. What's in here? Function, configure. Let's go through all these. Pops up over here. Configure, display, adjust, save, update. Okay, so using this knob over here to change these, and that actually lines up. So this side goes down, that goes down, which is nice. Sometimes they work backwards. So configure is this section. Then we've got display options. This is the adjust options, save options. There we go, and update options. That's what it's just like a, I don't know, a tab system, I suppose you could say. So tabs for these buttons over here. Languages, English, cool. So English, Chinese, looks like. We obviously want English in this case. Key lock. Press menu key, then force key. Repeat 3 times to unlock. Menu, force, menu, force, menu, force. Unlocked. Okay, I guess it's so if you get it set up you want to make sure it doesn't get changed, you could do that. I don't know, maybe it's for learning environments maybe, I don't know. Could be. Device, PC, USB, TMC. So it's obviously for the USB ports. You can choose whether you're using PC communication or whether you're using a USB drive. Although there are 2 USB ports. You've got this one here on the front and the other one that's on the back. And utility, about, information about the unit, serial number 9, SN 9 and SN that, and version 3.1. So go to display, you can then change backlighting, graphical types. I think I'll go with this one. Backlight 100%. There we go. So I'll just leave it 100 because you can see it on screen then. Menu time, it means the menu automatically shuts off after you've used it, so it will go away. Just like that. That's pretty nice. Adjust, let's go to adjust. Self-cal default probe channel. Use probe to connect standard signal. Don't know. Anyway, self-cal, I'm not going to do that right now. It's only just been on for a little while. Save options, so type waveform, type configuration, or image. I think I prefer waveform. You can choose the source, object on and off. You've got different waveforms you can choose. Curious. Formats, bin. Format is bin. Storage. Internal storage, it's got internal memory, not just relying on USB, which is nice. Okay. I don't think I missed anything in there, did I? In the update menu, which I'm not going to do, because I don't have an update for it. That's that menu system. That's quite nice. It's actually quite a nice little interface for a lower end, more budget conscious scope. It's a nice system. I'm actually pleasantly surprised. Okay, so next thing we've got cursors here, so I'll turn channel 2 back off again for now. Get rid of it. Cursors. So we've got a little pop-up, come over here. So measurement information. And we've got voltage, time, so you can see the cursors and these lines across the screen here. Maybe you can't see them too well because it's not particularly bright, but the lighting here washes things out. Auto cursors. So it's measuring 2.5 volts, 2.5 volts peak, and the delta is 4.92 volts, so 5 volts peak to peak. It's got some times in here as well, telling you the frequency and times and what have you there. Okay. So that's auto cursors. Can we adjust these? Here we go, there's the cursors here, A and B. So say we stick that cursor on there, push that. Oh, that's that one again. How do I change the other cursor? I zeroed it. How do you change cursors? Do that one. Time. So there, usually you click and you'll get it again, but it's actually centering it. That's a little bit curious. I need to figure this out. Linearity type, none. Window main, line, there we go, so we've got to do is push this. Here we go, that explains it. Okay, here we go. Look at the screen Poppy's got. So line A, line B, we'll then move this one. So then we can work out the timing between those 2 points. And that tells us 1 kilohertz. Right here. That's nice. Okay, right, now I actually look at it. That's fine, that's what you expect it to do. Makes a bit more sense. Voltage and time, so you can do these. line type voltage time, so you can adjust them independently, do two measurements at once, and over here will display it. Okay. Auto cursor. That's cursors. I don't tend to use cursors myself for anything. I've used it once or twice, not very often. I tend to have measurements running continuously at the scope, work it out, and then I'll just sort of see if it looks about right or not. Acquire menu. Sample, peak detect, averaging. So we've got 4, 16, 64, 128. Averaging is really good for getting rid of noise. So this is actually quite nice. It's got easy to use averaging actually. You can get in there, sample, peak detect, and averaging. See how much that cleans it up. That's pretty impressive actually. That's nice. Type vectors and dots. Now this is one of my little favourite things to check for, is to see how this ends up looking. Stretch it out. Still seeing vectors. Oh, is that dots? No, still vectors. So although it says vectors and dots, you can see dots now. There's dots in there. Dots. Less dots. So it looks like it switches to improve the display quality. And it's probably doing a combination of sampling, like the acquisition dots, and the screen resolution dots. Sometimes there's two different methods of doing it. And it will be acquisition, which is one you really want to know what's going on. You can see the dots in here. Usually see them on slopes better. They'll show up slightly better. But it looks like there's actually two dots side by side. It's a bit hard to see. But there's two dots side by side. And what I think that means is it's got interleaved memory. And that slight difference there is the meshing of the memory being put back together again. I believe that's what it is. I'm not 100% sure. Resistance mode, 1 second, 2 seconds, 5, infinity, off again. XY mode, it's nice to have. And also go on to this screen type, that's quite nice. When I switched over to it, turn it back off, goes back. Got the counter built in, cool. So we'll turn it on, we'll leave that turned on, and we'll leave the counter turned on, turn it back off. Right, measurements, channel 1, we can choose what ones we want to see. So we've got period, frequency, mean, peak to peak, RMS, max, min, and top. So here we go, that's all of them. I'll come back in a minute once I figure this out. Okay, figured it out. So we go back in the measurement again. So I did. So channel 1 selections, we can choose which one we want. So if we want peak and peak, just push that button again. And it's added it here, and it's appeared over here. So if I come down to RMS next, we'll add that one as well. There we go, RMS is here now too. So VPP, VR. And we'll also do frequency. I like to have that frequency listed as well, even though it's got a built-in counter. Nice little comparison here between what you see on screen and what the counter thinks as well. We will check this counter accuracy too, we'll do that. That's all the measurements I want from channel 1, that'll do. Was there anything else we could add? Also do the same for channel 2. I've done the show all thing, which shows you everything you can measure, which is nice. You want it like a snapshot. Obviously it covers up the screen, that's any problem. Right, so that's that part done. Horizontal time base, what's it we've got here? So this is like a zoom mode. Alright, so you've got normal and you've got zoom, and if you change the time base, you can see here it's got two lines which represent the bit you're looking at within the actual sample, and here's the zoomed look. Alright, so that's actually quite nice. This is actually quite a nice little responsive scope. I'm actually surprised. It's actually doing very well, especially for the money you're talking about these things. So that's what horizontal does. Zoom factor times 1 also displays it just here as well, what it shows you what you're doing. And also the time as well for the zoomed. Okay, so instead of really saying horizontal, I should have said zoom really, I think. I'll turn back off again. Let's look at channel 1 menu, then we'll go to math and those other things. So channel 1, coupling, AC, ground, DC, all standard. Inverted, so you can actually swap it around, apparently. That's curious the way it's doing that though. Is that the triggering? Don't know, that's a bit interesting. Not sure why inverted would do that. Probe compensation, I know it's doing it the whole time. It must be a triggering thing. Aliasing from triggering. It must be. It could even be that I'm overdriving it a little bit or something. Maybe the levels are too high. Possible. So probe 10 times, which is what we're currently set to. Measurement currents or voltage. So this here is saying voltage, here it's saying current. So if you're using it as a current probe, you can do it that way instead. Limit, 20 megahertz limit as is normal. So 20 megahertz bandwidth limit. So if you want to try and cut high frequency noise out and stuff like that, because you don't need to measure above 20 megahertz, then you can turn this on. Quite a common feature, just about every single scope has it. In fact, I think every scope has it. I think I've come across one that doesn't yet. So that's that part. Math function. So we do maths on channel 1, channel 2. Addition, subtraction, multiplication, division on each one. Vertical division per each one, you can scale that as well. FFT, has this FFT as well, that's nice. And you scale this as well, horizontal. What's the maximum here? 625k or 125k a division. So that's the options for that. So that's right, I suppose. So math and FFT. I think FFT is probably the thing I'd use more than math, but math can be handy. Okay. So that's that part. Turn that back off again. Channel 2 is also going to be the same as channel 1 as far as the features it has in there. I'm not going to use that. The trigger menu here. So you've got single, alternating trigger, which will trigger between different channels. So alternating trigger will trigger one channel, then the next one. This is interesting why it's doing this aliasing though. Edge, video, edge, source channel 1, channel 2. Nice and quick to change. Mode, auto, normal, and single. So it's a single capture, and then I suppose you can do full scan here. No. Run stop. No, it goes straight back in auto if you run stop. Unless you're in normal or auto mode. How do you trigger a single capture then? I thought I'd be pushing a single button here, but that's not doing it. Well, the force button. And pushing that makes it go back in auto. Curious. Another thing to figure out, I suppose. I don't know. Next page. Coupling, DC AC coupling as normal. Rising and falling slope. Hold off, which is nice. I'll be using that soon to do a test. Hold off reset, which is even better, because nothing worse than actually doing a hold off change. Come back. Menu. Hold off. And you can also do it this way, which is nice too. That's a nice touch. Winding the hold off up and down by the smallest number is a real pain. If you have to do that, it means you can ramp it up pretty quickly and down pretty quickly. So that's quite good. And then reset will go back to the default. That's nice. So this is actually a quite well thought out user interface. And obviously you've got the false thing which does something. I don't know. Yeah, curious. And copy waveform off because I'm currently stopped. Here we go. We'll start it. Bring that down a bit. Do a copy. I don't know. That does something too. I don't know. It's not something I'll probably use anyway. So let's actually put some other waveforms into this thing, give it a run through and see how it handles what I can throw at it. I've got some test waveforms I use and I'll see how it can do it. Alright, so I'm currently injecting a 1 megahertz signal. Basically exactly 1 megahertz would be within reason because I've only just turned on the RF signal generator. So over here we've got the frequency counter, which is probably a hardware frequency counter I'm guessing, and it's showing it's being slightly off, but not by much. What's that? 60 hertz off, which isn't too bad. And it's got 1 megahertz shown up here based on the waveform itself. I don't think the resolution would improve. Yeah, only for aliasing, got aliasing there. So if you go too low, you get aliasing, but that's normal. And yeah, see now, once you get a couple of waveforms on the screen, you can calculate all the frequencies here. So this is based on the measurement of the screen, and this is a hardware counter. Okay, so this, as you can see, is doing basically 1 volt. Let's get slightly closer, and I'll try and get this cable out of the way as well too. There you go. It's a slightly better view, isn't it? So it's got a 10k memory depth at this particular speed. So if I bring it down, does that change? Still 10k. Really bad aliasing at speeds. That's fine. So the depth isn't really changing. Yeah, it stays at 10k the whole time. Peak detect averaging doesn't really help that either. So back to sampling. Okay. Hide the menu again. So let's have a look at some frequencies in here. So let's bring this up a bit. So that's 1 megahertz. We'll go to 10 megahertz. I'll check the bandwidth first. What do you reckon? So that's 10 megahertz. It's dropped very slightly, but it's still looking okay. Let's do 50 megahertz. Okay, got some aliasing going on. Let's bring this up. And you can see it's getting a little bit jittery there, 50 megahertz, but it's not too bad. That's not bad, 50 megahertz. But as you can see, the voltage dropped a little bit here. So 0.707 or thereabouts, about probably 710, you know, because it was slightly above, will be about 3 dB down. So let's do 75 megahertz. Okay, 720. It's looking like it's meeting its spec so far. Let's do 85 megahertz. Still okay. 100 megahertz. Look at that. It meets its spec. If anything, very slightly past it. Let's do 105. Yeah, there we go. That's about it. 105 megahertz. So that's good. It actually meets its spec of 100 megahertz. So well done. And the sampling rate is actually looking pretty good. Right, so I can speed it up a little bit. And you can see there is a little bit of jittering in there at that particular time base. As I slow it down a bit though, it gets a bit better. So what I might do is go back into, let's put that to the fastest speed it's got. Acquire, we'll go back into dots. I'll see how that looks on screen. It's looking alright. There you go, you can see the dots in there. Alright, so those are the sampling dots, and this is why you get aliasing when you get down to certain speeds, because it can't do the maths on those dots because it's just a bit too much. So I think this is actually a combination of display resolution dots and sampling dots. It's not quite right because the dots increase when you get to this speed here rather than reduce further. So you're not actually seeing the sampling dots. Right, the idea of dots mode is you can see where the samples are, and this isn't really where it is. I think that might be it there. I think those are the real dots there. So that's one of my tests of seeing where the sampling is. This is a mathematical version of what it's actually getting, I believe. So it's not looking too bad though, it's actually looking alright. So let's go a bit higher in frequency. Let's go 150 megahertz, see if we can do that. It can. It's dropped down a fair bit, but it's okay. I just want to see when I can see the waveform getting really distorted because it can't actually sample it properly. 200 megahertz. Let's increase the vertical resolution. And why is that going like that? Is that not centered properly? It's centered. That is centered. But the aliasing at that frequency is causing problems. Or is it just triggers in the wrong place? There we go, triggers in the wrong place to do that. But it is sitting down here for some reason. I don't know why is it sitting down. Well, I've gone to that. So it might be the sampling, and you can see it's jittering around. So it isn't getting proper samples at that speed. But that's 200 megahertz. The counter's lost it. Increase the vertical resolution again, but yeah, it's weird the way it's diving down. So if we reduce the frequency to 100 megahertz, sorry, 150 megahertz, do that, and it's still sitting there. This is interesting the way it's actually going downwards. Have I left something turned on here, which is inverted? No, inverted is not turned on. It's got DC coupling. Maybe we'll go to AC coupling and see if that solves that problem, shall we? It's still diving down. Isn't that curious? Make sure everything's all set to be in the middle. It's still going downwards. That's a little bit weird. I mean, we can raise it up, but I'm just surprised it's acting that way. It should be sitting centered on the screen. That's interesting. Anyway, 20 megahertz, back to 200 again. 250. There we go, it's jittering around a lot there, so it's obviously completely unusable at that sort of frequency. But 200 is not that bad, actually. 200 is probably usable. So that's pretty good. And surprising. So back to 100 megahertz. There we go. And you can see it's come right up again now. But the way it's drifting off, maybe I need to do an auto cal now. Maybe I should do that, or self cal, whatever it's called. Utility, configure, adjust. You want adjust, self cal, move all probes. Yeah, okay, we'll take this off. Let's do a self cal. Yeah, it's been on for a while. There's no harm in doing it. And push the self cal button. Let's do that. Maybe that'll solve that problem. I'll come back once it's done. Okay, self cal is finished. Let's push that back to center again. Put the probe back on. The cable back in. And we'll increase the time base again because it's obviously dropped right down. It's all zeroed itself. And increase the vertical resolution. Alright, so now let's go to high frequency again, see if we get the same result we were getting before. Now it's done that self cal. So 200 MHz. And let's try and do this without my arm being in the way. Wind up the vertical. And it's still offsetting. It could be something to do with aliasing. It could be the way it's aliasing on that sample where it's detecting the lower end of the sample rather than the positive side of the waveform, but the negative side of the waveform. But then it is 200 MHz, so you know, it's way above where it's supposed to be. So 100 MHz, and we want it back up again, and that's looking pretty fine. Really? That's looking alright. That looks good at 100 MHz. So at the frequency it's supposed to be able to work at, it looks fine. So now I need to do my next test, which is to shove in a 10 MHz signal with a 1 kHz AM modulated signal on it. So it's modulated, and then see if we can capture the modulation waveform, because not all scopes can do it. In fact, very few scopes can do it unless they've got a really good acquisition system or good hold-off setting options as well. So I'll try and get this set up and see if I can get it. I'll do it off camera so I won't waste time, but I'll come back if I can get it right. So here is a 10 MHz signal which is being modulated by 1 kHz at 90%, and you can see the way it's waving around all over the place, right, which is completely normal. So what I need to do is bring it down. It'll be around here somewhere, right? This would be the modulation. I'm not quite sure what the frequency is supposed to actually be for the time base, but it'll be around here somewhere. Okay, this is going to be kind of the modulation frequency around here, but because of the aliasing and stuff like that, it needs to be able to try and find it. So what we need to do, I think, is go to a trigger, hold off. We need to set the hold off, wind this up, and you can use hold off to adjust how it handles the samples. Okay, so if you get this hold off time set correctly, you can actually see the modulation waveform. Closer. I just figured out I had the wrong setting on here. On the acquire menu here, I had averaging still turned on at 4. So now let's try this again at sampling. Aha! I cracked it. I turned on peak detection, and now there we go. There's the modulation waveform. That's what I was missing on that one. So yes, peak detection is working on this one. I've done this on other scopes before and it hasn't worked, but this time it did work. So that's good. So there is the modulation waveform. Exactly as it should. 90% modulation. Now the triggering I've got set quite high. See, I've got it up here. I'll probably drop it down a bit now. See, it's a bit unstable there. Let's go a bit higher. A bit there somewhere. There we go. So the hold off's probably not quite right still. Well, it's not at all right now. I'm going to play some more actually, so I can get this a bit better. It can do it, so yay. So if I change the modulation level, we should actually be able to see this shift with it. So I'll do 50% modulation now. There we go, 50% modulation, that's correct. So, excellent. I think I might keep this scope for myself and put this in my radio lab because my other scopes couldn't do this. Maybe I need to relook at this peak detection though. Maybe it's what I was doing wrong in the other scopes, using peak detection. Now, my other scopes, like my Siglents, can do this easy without using peak detection, just normal triggering and normal acquisition, and it's fine, it can do it. But obviously, because of the resolution of these, it needs a bit more of a focus on those instantaneous events in that larger waveform, so it can do it. Well done. Excellent. So yes, that's very good. I'm actually really pleased with this scope. It's actually a nice scope. It actually works quite well. Meets its spec. It can do this hard test, which is this modulated waveform, which a lot of scopes fail on or struggle with, and it's managed it. Nice display, fairly quick to respond. It's a good little scope. So make sure you go and follow my links to Banggood here, go to the site. So there's links down below in the description. Click the show more tab down the bottom there, and it will open it up and it will have links to Banggood for this scope. Okay, so this will be straight to it. I'm not sure if there will be a discount code or not. Sometimes there is, sometimes there isn't. I'll have to recheck on that. There could be a discount code. Often Banggood will do one for me. You get a slightly better price. My opinion to this scope, well, as I've just said just now, it's actually surprisingly good. Surprisingly good. Catch you later. There you go, buy one. Bye. Subscribe. Thumbs up. Check the videos at the end. All that stuff. Yeah, bye now. Something else I'm also thinking about is doing a oscilloscope review. That's not right. This is review. So I've hooked the front channel.